Hello, my DevNation friends. Welcome to another Tech Talk. Today's very special guest is a brilliant engineer that works with the Infinispan team, and she'll be able to share some amazing cool stuff and maybe share even some demos regarding some games that you've seen in the past. And I was just talking to her before we joined the stream, and she's a Spanish person that lives in France. So she has this very charming accent that you'll be amazed just as myself. So welcome to the stage, Katya. Welcome, Katya.
Hello. How are you?
I'm good, and
Very,
you?
very happy to be here.
Awesome. We are more
Yeah.
than happy to have you today. And I was mentioning Katya apparently is streaming from Paris, France. So
Yes, I am.
how's the summer in Paris?
It was hot and now it's cold again. I don't understand. It was like tropical climate at a moment, like raining, very hot, then it's cold. But anyway, now we are almost off lockdown, so we can go to restaurant and do things again. So I'm pretty happy to be here.
Okay, yeah, being able to enjoy the amazing
Yeah.
food and wine from France. Well, it must be. Now I'm super eager to do that as well. All right, yeah, and Katya, let me ask you: are you a tabs or a space person?
Well, I'm a Java developer. I use IntelliJ, and the thing that it's configured over there with my formatter, and that's what I use. I don't have any strong opinion on that. Depends
Okay, perfect.
on the language. Yeah.
Yeah, it doesn't matter. The
No.
code is more important.
Yeah, I don't have strong opinions on that.
All right. So let's go to our presentation. So today, live from Paris, France, and Cary, North Carolina, welcome to DevNation.
Yeah. So welcome to my real-time data and statistics on the Open Hybrid Cloud with Quarkus and Infinispan. As Edson has already presented me a little, I'm Katia Aresti, and I'm a senior software engineer based in Paris, but from Spain. I'm part of the core Infinispan team since 2017. I'm also part of Duchess France and the DevOps France organization team for several years now. Duchess France, that is a Women in Tech Java user group. I'm Java champion since 2019. I had the chance to be part of this team for 2 years now, and you can also follow me on Twitter on KRST. So so this year I participated on the development of this Battleship online game that it was human versus AI, where you needed to play. So to play this game Battleship, you place your ships, you take your shots against an AI opponent, and the goal was to sink all the ships or either lose your game. If you were as bad as I was, that I lost like most of the games I played. And during this game, a part of the gaming and the matches, on the left, we had these top 10 players that was getting refreshed to get all the top 10 players ranking, and some statistics as well of how many players were playing at the same time, how many games were won, lost, different ratio between AI and humans, hits and misses, and so on. And this leaderboard and statistics was, as I said, calculated on real time all the time. So this game had a very big architecture and many components and technologies involved. We deployed this in the Open Hybrid Cloud in 3 different clusters: GCP, AWS, and Azure, in Asia, America, and Europe. And so the interface for the game, it was interacting with a Node.js application for all the gaming and the administration of the game. And this application was storing the data in memory in Infinispan. So all the matches and players and so on. After, there are other components here, managed Kafka, cloud events, serverless, that were dealing the AI, another other bunch of things, and the scores. So at a moment, the players are getting delta scores and scoring depending on hits and sunks and misses and so on. So the scoring API built on Quarkus was storing these scores and updating them in Infinispan as well in memory. And then the leaderboard and the statistics were gathering this data continuously and exposing them through a WebSocket to this leaderboard. So the matches and the players were data that was local for each of the clusters to be geographically close to the users or the players, but the leaderboard, however, needed to be global and take into account all the players' scores in the 3 clusters across the globe. So this talk is what this is about, is explaining how we did this global ranking of top 10 players with Infinispan and with Quarkus. I will explain a little the key features used on Infinispan and Quarkus to develop this use case. And at the end, I will do a local demo of this leaderboard as well. So first, a small little talk about Infinispan. So Infinispan is a 100% open source in-memory distributed data. Distributed caches, right? We always listen, Infinispan are distributed caches. So the 5 key features of Infinispan is the first one, interoperability, especially on client-server mode, since Infinispan can be embedded in your Java application, but also it's deployed. It's the most common use case nowadays, deploying it in client-server mode. So the data will be in the server of Infinispan, and the clients will connect either with Node.js, with Java, or C#, for example. Another is the resilient and fault tolerance data. We can configure different levels of consistency depending on the needs, or different levels or different strategies of availability for different use cases. ACID transactions. Infinispan caches can perform ACID transactions in memory as well. Clustering processing, and querying, performing full text queries over values in Infinispan caches. So going into the Infinispan client server, which was we deployed 3 different clusters in different sites using the Infinispan operator, the Kubernetes operator, that helps us really to get up and running a cluster easily today in Kubernetes OpenShift. And then we have this over code using different clients. Well, we didn't use any C# microservice, but I put it here to give a bit of credit to the new .NET client that has been published not a long time ago. And then, so the client connects to the server through the hot rod binary protocol. We also have REST APIs, but well, the most common use is embedding your client in your application and using the hot rod binary protocol. The most simple cache configuration for the player scores, where we stock them, could be something like that, like saying, okay, I have a distributed cache that is synchronous, and I wanna activate statistics so I can see different statistics on this cache in Infinispan. How can we create this cache? We can do it either on code with the API. We can configure it on the Infinispan XML on the server. We can use the command line tool, or the Infinispan web console, or the Infinispan operator, the Kubernetes operator. For the deployment we did in Submit, we used the operator. We configured everything over there. In the final demo, I will show you how we can do that with the Infinispan console as well. So as I said, we are always talking about caches, expiring data, caches are gets and puts, and that's all. And we forget about this key feature that is Infinispan query. With Infinispan query and with the Infinispan Quarkus client extension, we can do these kind of things. So we can inject a cache that already exists in our Quarkus microservices, and then using the query language and the query API of Infinispan, we can perform full text queries and sorting queries over the values of the caches. So for example, for the top 10 players, we can say from com Red Hat player score, were humans true? Because, yeah, Burr said, we don't want to give any credit to the AI bots. And I do agree. We weren't just the top 10 players humans, ordered by a score. So with this query, doing top 10 query, execute list, max results 10 over here, we had the top 10. So this is on the code. But there is other things that we need to configure to make this possible and to use Infinispan with query in the best way. The first thing is that we need to realize that, yeah, we are serializing data between an application and the server. Data needs to be serialized. And Infinispan stores the data in different formats. You can store it in using Java serialization and store Java serialization. Then you should use the Java marshaller on the client side to read and write Java marshaled objects. However, you can also use JSON, XML, or text. But if you want to get the max interoperability and the full support for queries as well, the recommended way today in Infinispan is storing the data in protobuf format. And for that, we use ProtoStream. ProtoStream, that is a serialization library, part of the Infinispan project that is based in protobuf. So we will use the ProtoStream marshaller, and protobuf will be used. The format inside Infinispan will be protobuf. In order to understand better how this works, we recently published a guide. I put a link here in the slides, so you can really understand the whole picture of and the implications of different formats and marshallers in Infinispan. So the ProtoStream API, it's, as I said, it's a library that it's part of Infinispan. And with Quarkus as well, it's integrated with Quarkus. It's the default choice for developing with Quarkus. And ProtoStream, what it does is, using annotations, we are able to create or generate the proto schema protobuf needs to be able to format, to be able to marshal and unmarshal protobuf formatted protobuf format. So, for example, here in our Java class that will be part of our Quarkus application, for example, we will put different annotations like proto factory to use this constructor to create my objects from protobuf format. And then proto field like this will tell ProtoStream which fields needs to be included in the protobuf serialized byte array. So then ProtoStream creates this protobuf proto file, and Infinispan server to be able to do to be able to marshal and unmarshal protobuf format. The only thing the server needs is the proto schema. So how can we do this? How can we put this proto schema in the server? We will see that we can use either APIs, either the console, or even Quarkus does this upload for you as well. From another side, we see that we have some annotations here related to indexing, because we are using indexed queries and sorting. The best thing that we can do to get search and queries work with the best performance is using indexes. So we can do some annotations put some annotations to say to Infinispan which are the fields that we want to get into the indexes for performing queries after all. So the configuration of Infinispan, there are two things that are very important. The first one is saying, okay, I want to use encoding media type protostream, which means this cache is going to store protobuf. And the second one is saying, hey, this cache is going to contain Red Hat player score entities that will be indexed because we are going to perform queries over them. So if I have 3 clusters with 3 queries performing with local scores, so I have 3 different rankings. So that's where cross-site replication comes into the game to make this global. Infinispan cross-site replication is one of the features that allows us to have backups of clusters. We can have one cluster in London in one side on AWS. We can have another GCP cluster in New York, and we can connect both clusters of Infinispan that can be completely heterogeneous. They don't need to be exactly the same, but we can connect them and say, okay, I want the London cluster data to be backupped in New York. So this will be active-passive replication. And if for whatever reason I lose the cluster in London, I can always fail over to New York. And we can also do active-active replication. And this is what we did for this global ranking. So instead of just saying, we put backups in all the caches that were involved, so the player score cache in this case. So the London cross-site, the London site with the player score cache, I configure backups and I say, hey, my backup for this player score cache is in London, or is in New York. And in the New York player scores configuration, I will say, okay, the backup for London, for New York is in London. So what we did is put in, we had 3 clusters, so each of the caches had 2 backups. So all the scores were getting replicated everywhere in active-active mode. Let's show you the local demo right now then. So here, sorry, I'm gonna do this. So I have in my local just a Docker Compose with two Infinispan running, but they are running in different clusters. So one is London and the other is New York. And this is something we can easily do in local for testing. So here we have on the left the London side that it's empty, there are no caches, anything, and on the right I have the New York Infinispan. So and I also run in local the front-end application that does the leaderboard, and there is nothing yet right now. So I'm gonna bring here the code of the leaderboard in Quarkus. The first thing to show up here is that we used essentially 3 extensions for this demo. So the Infinispan client, the WebSockets, and the scheduler. In the application .properties, we are saying, connect me to localhost 11222. And this is that it's going to connect to the London Infinispan. The New York one, it's not getting any connection right now. The player scores, as I said, has the indexing and the protobuf annotations over them with all the fields and all the fields that are involved on indexing or all the fields that are involved in the protobuf serialization. To create an schema that contains more than one field, I'm going to say, okay, you are going to build me an schema where the package name is Red Hat, and I'm going to include this class and this class and this class. Well, these classes are not part of this demo, but this one is. The leaderboard endpoint is the WebSocket using the WebSocket extension, where I have my player score cache. And what I do is I schedule this method to be executed every second, 3 seconds, 4 seconds, depending on what we need, and execute this query continuously. From Red Hat player score, this is the package we set over here, where humans, the thing I showed in the slides before, max results 10. I convert this into JSON and I push it to the WebSocket. And that's pretty all. So I'm gonna run the Quarkus application. In this Quarkus application, as it's running in development mode in local, I have some code that is going to create random data to simulate that there are players that are working. So if now I'm coming to my console here, I say, there I have some caches that have been created. And if I refresh the board, it's connecting to the WebSocket and it's simulating people that are playing and getting updates every second. So let's just grab a quick look here to the Infinispan London console. As I said, the New York one is not yet involved. So the first thing is that we see that the schema has been uploaded. So we have a proto schema over here, generated here on the leaderboard, where we have the proto schema over there. So the player score cache, we can see that we can grab the information in JSON mode. And this is what I talk about interoperability. The fact that we have protobuf on the server makes it very easy to do interoperability between Java and between JSON classes and displaying, because this application is a pure front-end React application that consumes RESTful endpoints of Infinispan. So here we have the content. We can see the configuration, a part of as I said, the proto stream encoding, indexing here. There are no backups over here. There are other stuff that are not important for the purpose of this demo. And as I said, that metrics are enabled. I can check different metrics over here, and even the queries that have been executed, I can see some stuff, some query statistics over there as well. And here we see that we have also this query tab. So I'm gonna move this over here briefly. And I'm gonna run a couple of queries to show you. For example, we can do a count like that. We can say, okay, I said select count user IDs from player score where humans and the score greater than 30, and I have 27. I can perform queries like that as well. From player score where humans true and the score from 35 to 50. And there I get, there are 7. Or full text queries like that over the name, for example, like this one. Red Hat player score where human true and username Maria. So here we have Maria 1, Maria 0, and Mari Carmen 1 and Mari Carmen 0. That are my girls, my Maria game. So once we've seen this, now I'm gonna try to hack using the New York site, and I'm gonna try to hack Infinispan and get into the leaderboard. So first, this is empty. I have nothing. The first thing I'm gonna do is create the same cache, player scores, and I'm gonna use the same configuration as the player scores in London that I'm gonna put here in JSON. The only difference is that I will say that this cache over here, the backup is London. So I create this cache. The difference you see here, it's indexed and backups, and this one is only indexed player scores here on the left. So if I come to this cache and I try to manage indexes and see what's going on, it's telling me, hey, you declare that you are going to index player scores, but I don't know what this is. I think you need to register in schema first. So yeah, as I said, we need only to tell the schema. So I'm gonna put a people.proto, and I'm gonna grab the same schema from the London site. And that is done. I have it there. So if I come back to my cache, yeah, now there are no entities, but it works. So now I'm gonna try to create an entity and hack the system. So I get this JSON over here. As you can see, it's a type com.player_score. I'm gonna say this is a human. I'm gonna call it DevNation hack. I'm gonna put a score of 3000 and key hack. I add this. Okay, this is added. How is done? Oh, the leaderboard has been hacked. This has been copied automatically to the London site. And if I go to London and I check for the hack key, yeah, it's here. And that's my demo. That's my demo for today and my presentation for today. So thank you very much for listening. I hope you like this demo. If you want to go further on Quarkus and Infinispan, follow Infinispan on Twitter, the Infinispan documentation website, the Infinispan client extension. We wrote 2 extensive articles about this on the Red Hat developers blog. And here is the link of the latest one, is the link for the replay of the Red Hat Submit demo. So that's all for me. Edson.
Awesome. Well, thank you, Katya, for this amazing session, amazing demo. Next time we have an online summit game, maybe I'll ask for your help so you can hack and maybe I can win some prizes. Who knows?
Yeah, I was thinking about that during the demo. I was like, I have access to the consoles of Infinispan. I could have hacked myself. I knew how to do it. I could have put myself the first one very easily, but I did. I'm a bit scared of Burr if I did that. So
you see, that's why it's important for you to know the right people. So. And we're looking at the chat, and thank you for Cloud Native Development. He was able to ask some questions, but I would like to forward one to you because I think this one is interesting. So Andres Leal was asking, how did the hybrid cloud intercommunication work? Was it over REST APIs? Did you use MTLS? And how did you handle security?
So for the cross-site replication, I guess that's happening in binary. It's not over REST. It's the hot rod protocol with relay 2. It's J groups underneath, and it's J groups that connects them. The security in general, it's encrypted on the between the data. It's encrypted when it's transferred. So More on that is Pedro knows better the details. Better, other people in my team knows better the details on exactly how this works. But that's the thing. It's not REST API. It's
Okay.
binary.
And you know that a lot of people that are watching us, they are wondering because when they think about cache, a lot of us heard about Memcache or even Redis before. Why should people think about adopting Infinispan instead of these other technologies? Do you have any insights about that?
Well, for me, one of the first insights is that Infinispan is 100% open source. So and we really and after Red Hat gives support with the Red Hat data grid, but the productization is very fast. It's really this development cycle between what is upstream and after. It's really fast. So you get all these features already that you can test and have access to something that has a very strong support afterwards. I don't know. I'm not an expert on Redis or others, but I know that when it comes to doing cross-site replication like that or scaling, it's not that trivial to do it. Infinispan might be. In the past, maybe it was harder to put it speed up and running, but today it's really easy. In less than 5 minutes, you have a cluster in local. You can test the cross-site replication just using 2 Docker containers. So and it's really a technology that is well tested in very big clusters around. And I mean, it's something that guarantees what it says. I can't say any more than that.
Okay, cool. And I've noticed, like in your slides, you mentioned that well, you can integrate Infinispan with Java, and you also mentioned that we have also a C# connector.
Yes.
Do we
Yeah.
support any other languages or platforms?
Not JS as well. I think there is a Python client as well, but I'm not familiar with it. And the C++, C#.NET. So the main ones are those. The Java one, it's the JVM, right? The JVM API.
Okay. So yeah, so probably your favorite language platform is already supported, so you don't have this excuse for not using Infinispan. All right, Katya, thank you very much for again, one more time for this amazing session and presentation. I'm sure that if you're watching this video, you also were as entertained as I was, and maybe you should be considering Infinispan for a next like large-scale, multi-cloud, inter-site replication.
We will more than happy to have more people coming to use Infinispan and after Red Hat Data Grid as well, of course.
No, I'm pretty sure they will after this presentation. And,
Thank you.
Katya. Thank you for watching as well, and see you at the next DevNation offering.